Welcome to this video about depth of field and depth of field scales. This is a manual focus 35mm film lens, a 50mm f1.7. The aperture ring on the lens is the one with 16 in green on it, and the focusing ring is the one with numbers in white and orange. The depth of field scale is between them and has aperture values on it that we can use to read distances from the focusing ring. Depth of field is the combined distance in front of and behind the subject in which things will appear to be subjectively in focus. We can use the depth of field scale to estimate this distance. At f8 and 2 meters focus distance, the depth of field scale indicates a depth of about 1.2 meters will be sharp. We can read the values of the distance from the focusing scale using the marks on the depth of field scale corresponding to f8 to give us the points on the focusing ring to estimate the distance from. This gives us a range of about 1.6 meters to 2.8 meters, 0.4 meters in front of the subject and 0.8 meters behind the subject. At smaller apertures such as f16, as depth of field increases relative to f8, as can be seen from the numbers corresponding to f16 being further apart on the depth of field scale. Now if we change the focusing distance to 1 meter, the depth of field shrinks to about 0.25 meters, as determined by reading the distances off using the f8 marks on the depth of field scale and estimating the depth of field. Now if we increase the focusing distance to 5 meters, we see that the depth of field at f8 increases to 7 meters. So depth of field shrinks with reduced focusing distance and increases with increasing focusing distance. So to recap, depth of field increases with focusing distance to subject and smaller apertures, and decreases with decreasing focusing distance and wider apertures. We will now have a look at how depth of field varies with the focal length of the lens by comparing several lenses focused at 2 meters and set to f8 and reading off the corresponding depth of field in each case. I have now swapped in a 35mm f2.8 lens set to 2 meters focusing distance and f8. And if we read off the distance from the focusing scale using the depth of field scale, we get the values 1.3 meters to 5 meters for a total depth of field of 3.7 meters. So depth of field on a 35mm lens is greater than for a 50mm one. I have now swapped in a 28mm f2.8 lens set to 2 meters and f8 again, and I've read off the depth of field from the focusing scale using the marks on the depth of field scale. The depth of field reaches from 1 meter to nearly infinity, so depth of field has increased again as we have shortened the focal length of the lens. I have changed the lens to a 50mm f1.4, once again focused at 2 meters and set to f8. Reading the depth of field from the focusing scale using the depth of field scale marks give a range of 0.6 meters to 1.8 meters for a depth of field of 1.2 meters. This is the same as with the 50mm f1.7 lens, so for a given focal length of lens at the same aperture and focused at the same point, the depth of field remains the same for the two lenses. I have now switched over to an 85mm f2.8. This lens is set at 2 meters focal distance and f8 again. So if we read off the distances from the focusing scale using the marks on the depth of field scale, we get a range of approximately 1.85 meters to 2.2 meters, which gives us a total depth of field of about 0.35 of a meter. So increasing the focal length of the lens has reduced the depth of field. I have now changed to a 100mm f3.5 lens, once again at 2 meters and f8. If we read off the depth of field values using the depth of field marks, the f8 marks are the ones inside the ones marked 11, which are for f11. We get a range of 1.9 meters to 2.2 meters for a total depth of field of 0.3 meters, which is less than the depth of field value we got for the 85mm lens, so depth of field has again decreased with increased focal length. The depth of field scales on the lenses that I've been using date from the film era and were used on 35mm film cameras, so the calculation of acceptable sharpness was based on a certain size of print enlarged from a 35mm negative. Things have changed in the digital era, and here we see a 50mm f1.4 lens from the same manufacturer from the digital era, and if we use the depth of field scale to check the depth of field, we find that the value of 0.75 meters is less than that of the other 50mm lenses, which was 1.2 meters. This is because the criteria used for acceptable sharpness is tighter for digital cameras, and this needs to be borne in mind when using depth of field scales, as they give approximate values, and the digital cameras may require a lower depth of field value to be used if a higher definition of sharpness is being used. This is also true in a general sense that depth of field scale values give approximate values that may or may not be adequate to yield an acceptable degree of sharpness in an image, and this needs to be borne in mind when using them, particularly if they date from the film era. Depth of field scales do not always appear on lenses, and not all lenses have them. On this 1950s TLR, the depth of field scale is on the metal plate behind the focusing wheel that moves the lens board. It works as previous ones shown, with marks either side of the point of focus for the f-stop, and the depth of field can be read off. In 120 film cameras, the depth of field is typically a bit higher than for 35mm lenses of the same focal length, as the negatives were enlarged a bit less for a given print size.